Lesson 8.4 is on multiplying and dividing radicals as well as rationalizing denominators. So introduced in lesson 8.2, we were given two rules for radicals. One was the product rule and the other one was the quotient rule. And we're going to be using these again when it comes to multiplying and dividing radicals. And basically we're thinking about them the opposite way. Before, we broke apart the radical into the two products, or vice versa, the quotient, and broke it apart into two, like the numerator and the denominator, and then took, the nth root of each of those. And so now we're going to basically be thinking of it as, okay, here's our multiplication problem, and we can combine it and then work with it to either simplify that or get a final answer. So the simplified radical expressions have to meet the following conditions. Number one is that the radicand has no factor that is a perfect power of the index of the radical. Number two is that the radicand contains no fractions or negative exponents. And number three, which we haven't seen yet until this lesson, is that the denominator cannot contain a radical. So if it does, for condition number three, this denominator containing a radical, that's when we use this process called rationalizing the denominator. And we're going to see examples and questions of that when we get to number 34 through 46 out of the textbook. But rationalizing the denominator helps us to get rid of the radical and therefore get this simplified radical expression. The first few examples we're going to take a look at are on multiplying radicals. And so for this first set of questions, we are multiplying and then simplifying if possible. So for this first question, we have the square root of 3 times the square root of 12. So using our product rule, we're going to multiply those underneath the same radical symbol. So we'll have the square root of 3 times 12. Multiplying those together, we'd have 36, and then taking the square root of 36, we would have just 6 as our final answer. For number 4, we're taking the fourth root of 5x times the fourth root of 15y cubed. So since these are both being taking the fourth root of each of these expressions, we can again combine this. So now it says 5x times 15y to the third power, all underneath the same radical symbol. And then multiplying this together, we'd have the fourth root of 5 times 15 is 75, and then xy to the third. And we cannot go any further with that. There is no perfect fourth root of 75. Our factor of 75, that would be something that you could take the perfect fourth root of. So this would be your final answer. For number 6, we have 4 times the square root of 3x times 7 times the square root of 6x. So for this problem, we're going to end up multiplying the two, basically, whole number factors out front. And so that's going to give us 28. So 4 times 7 is 28. And then these two here, we're going to have the square root of 3x times 6x, again, using that product rule. So now we're going to have 28 times the square root of 3x times 6x, which is going to be 18x squared. And this is where we have to go a little bit further with this question because 18 has a perfect square factor of it, and x squared itself is a factor that you could take the square root of. So now this is going to be 28, and we're going to break apart the square root of 18 so that we have the square root of 9 times the square root of 2, and then this x squared on its own. So we're almost now using the product rule in reverse compared to what we had done at the start. Taking the square root of what we can, we're going to end up having 28 times 3 times the square root of 2, because we can't go any further with that one, times x. And then rearranging our terms here, or not rearranging it, excuse me, we have to multiply this out. 28 times 3 is going to be 84, and then times the square root of 2, and then x. And we actually would just leave our answer like this because this right here is the coefficient of x. So we write the x at the end, and just be careful not to write it too closely to the square root of 2 so that it looks like it's underneath that radical symbol. Otherwise, that could be misread or misinterpreted. So make sure you keep the x separate from the square root of 2. And then that would be it for that one. Question number 8. Moving forward to this question, we have the cube root of 9x squared times the cube root of 6x squared. So again, using that product rule, we're going to have the cube root of this 9x squared times 6x squared. Multiplying that out, we'll have the cube root of 9 times 6, which is 54, and then x squared times x squared would be x to the 4th power, because again, with our rules of exponents that we were introduced to back in chapter 5, you add those exponents, so 2 plus 2 gives us 4. So now we have to figure out, okay, is there any perfect factors for 54 that we can take the cube root of? And same with the x to the 4th, and we can actually do both of these and find factors that we can take the cube root of. So 54 is going to break down into the cube root of 27 times this cube root of 2. So the cube root of 27, we're going to actually be able to evaluate that part. Then we're going to break apart x to the 4th. We're going to write that as the cube root of x to the 3rd times the cube root of x. And again, we're going to actually be able to take the cube root of this x to the 3rd power. So now we're going to have the cube root of 27, which is 3, times the cube root of 2, times this cube root of x cubed would be x, and then cube root of x we can't do anything further with, so we leave it as that. And then just rearranging our terms and then combining this cube root of 2 with this cube root of x using the product rule for radicals, we'll have 3 times x, so 3x, and then we'll have the cube root of 2x underneath that radical symbol. And that would be the final answer for that question. Number 12 now is a little bit different from the previous problems. We're going to actually use the distributive property on this question. So we have the square root of 2x times the quantity of the square root of 6x minus 5. So we're still going to be using our product rule in this question. It just looks a little bit different because, again, we have this whole quantity that we're multiplying by the square root of 2x. So this is going to be equal to the square root of 2x times the square root of 6x minus the square root of 2x times 5. So all we did here was distribute that square root of 2x to each term inside the parentheses. So now what's going to happen is we're going to actually be able to multiply these together. And so this is going to end up being the square root of 12x squared. And then this we can't move forward with any further. This is going to just be, for the time being, minus 5 times the square root of 2x. And then now here, the square root of 12x squared, we can actually, again, your goal is to basically factor out anything that you can take, you know, the square root of, or in the last example, we took the cube root of. So you want to get those factors out. And with this one, the 12, you can break this down into the square root of 4 times the square root of 3. And then this x squared, you're actually going to be able to take the square root of as well. So we're going to break it apart into that. And then we still have this minus 5 square root of 2x on the end. Now here we'll have square root of 4, which is 2, times the square root of 3, times x, and then minus 5 times the square root of 2x. And then rewriting this just so that we don't have all the multiplication symbols in between there, we're going to write this as 2 square root of 3, so same situation as last time. Be careful not to write this x underneath the radical symbol, but this is the coefficient of x, minus, and then 5 times the square root of 2x, and that 2x again is all underneath the radical symbol. And that would be it for that question. And then our next example that we're going to take a look at is number 14. And this again is the same idea as the last question. So we're going to be taking this cube root of x and we're going to distribute to each term inside the parentheses. So this is going to end up being the cube root of x times this cube root of 54x squared minus the cube root of x times the cube root of x. So this here is going to turn into the cube root of 54x to the 3rd. And this here on the end, the cube root of x times the cube root of x, that's just going to end up being the cube root of x squared when we do the x times x. This here is actually the same situation, or very similar situation as what we saw up in number 8, except for instead of having x to the 4th, we actually have x to the 3rd. But we're going to break apart the 54 so that it looks just like what we had up here. So we're going to rewrite this as the cube root of 27 times the cube root of 2 times the cube root of x to the 3rd this time. Last time we had x to the 4th, this time we just have x to the 3rd. And then at the end of this, we still have this cube root of x squared, which we won't be able to simplify any further. Now moving forward with this question, the cube root of 27 is 3 times this cube root of 2, because we can't do anything more with that. This cube root of x to the third is x. And then again, we just have this cube root of x squared on the end. And so now rewriting this question, this is just going to be 3 and then the cube root of 2 x minus the cube root of x squared, which again is all underneath that radical symbol. And that would be the final answer for that question.